Am I audible?
Good afternoon, sir.
Yeah, good afternoon, Bhaskar.
Sir, how are you, sir?
Yeah, I'm doing good. How are you?
Sir, fine, sir.
Okay.
Sir,
Actually, some topic is given. Examples of successive approximation register ADC. What is that? In your slide. Okay. Okay, please go ahead.
sir, 1 second, sir.
Yeah.
Sir, let me start the session, sir. Sir, let me start the session, sir.
Yes.
Okay, sir. Very good afternoon, participants. I would like to welcome all the participants for a day 9 session 2 of AICTE sponsored 2 weeks online faculty development program on emerging trends and challenges in a VLSI mixed signal processing for a fourth industrial revolution. Welcome you all. It's my pleasure to welcome our today's resource person, Dr. R. Murugan, Assistant Professor, Department of Electronics and Communication Engineering, National Institute of Technology, Silchar, Assam. Welcome you, sir.
Thank you.
When life puts you in a tough situation, don't think why me, just think try me. I'm saying about the person who is none other than our resource person, Dr. R. Murugan. Let me know you about his biography. He received his BE degree in Electronics and Communication Engineering in 2005, an ME degree in Embedded System Technologies in 2010 from Anna University, Chennai. He received his doctoral degree from Information and Communication Engineering from Anna University, Chennai. He's having 11 years of teaching experiences in various course at reputed institutions. He published more than 26 journal publications, 22 conference proceedings, 2 books, 9 book chapters, and 4 patents in his career. Presently, 9 research scholars are doing their PhD under his guidance. His area of interest, which includes biomedical signal and image processing, medical imaging, retinal image analysis, computer vision, pattern recognition, machine learning, and deep learning. He is the reviewer of many reputed journals such as IEEE Transaction on Medical Imaging, Biomedical Signal Processing and Control, and etc. He received the Best Reviewer Award from the Elsevier Journal Biomedical Signal Processing and Control in 2016. He received a Young Scientist Grant from the Department of Science and Technology from Government of India for the project a national-wide study on a retinal detachment in India, which emphasizes on the risk for the fellow eye through funds images deep learning in 2020. In this way, I would like to hand over the session to our resource person, Dr. R. Murugan. Please, sir.
Yeah, thank you, Mr. Bhaskar, for a nice introduction. Yeah, okay.
You can share your screen.
Yeah. Okay. So, is there any title has mentioned for my presentation?
Sir, just leave it, sir. You can continue the session, sir.
Yeah. Okay, fine.
Okay.
Yeah, thank you. So good afternoon, all of you. Basically, I'm working on biomedical images and especially the medical imaging perspective. So as far as this FDP concern, the scope of this whole FDP is mixed VLSI circuits and and related applications. So this particular talk I have been going to present with a combination of medical images with this hardware implementation. Let's say exactly as we know, in any type of medical imaging problem, so basically we have to use all the simulation tool and other things. But apart from that, we have a lot of hardware to implement the same. So this particular deliverable, I'm going to deliver both how we can effectively use the software algorithms for implementing the medical image diagnosis. And of course, while using this kind of software tools, what are the challenges are available and how these challenges may be addressed with the help of hardware. And in a lot of VLSI circuits, let's see if we consider this field programmable gate array logic, FPGAs, we have a lot of advantages in this regards. So in this talk, I'm also going to cover how we can use FPGA for addressing for time complexity problems of medical images. Okay, so this is the plan of my talk. So with this, I just want to share my screen. Yeah, can you able to see my screen?
Yes, sir, visible, sir.
Yeah.
Okay.
So, so this talk, so basically, I'm going to deliver, one of the very important medical imaging modality, which is called retinal image. We can say the retinal fundus image. Okay, so how this retinal fundus image can be utilized for diagnosis of various eye diseases, and of course, how that we can able to use this FPGAs for the diagnosis of this eye-related diseases. Okay, so this is the overall plan of the today talk. So before proceed further, I would like to say some of the historical information about my institute. So I belong to this institute, the National Institute of Technology, Silchar. It is located in the northeastern state of India, in state Assam. And this is one of the reputed, we can say the technical and research institute in the country. And of course, this NIT Silchar is one among the 31 NIT in the country. So this institute was started in the year 1967 as a regional engineering college in Silchar. And later, according to the NIT AICTE, this is migrated into NIT. So basically, as a technical institute, it is offering a lot of postgraduate and undergraduate and doctoral philosophy programs in the field of engineering and science and humanities. And of course, the main backbone of this institute is that it offers a lot of postgraduate programs in the field of engineering, science, and management. So this institute is having a lot of infrastructure facility for the betterment of the employee of the institute. And of course, this recently, in last year 2019 NIRF ranking, this institute was ranked 47 among the engineering category. Currently, this institute is headed by the director, Professor Sivaji Bandyopadhyay. Is a professor from Jadavpur University, Kolkata. And I'd like to show the drone view of the whole NIT Silchar campus. You can see here a lot of water reservoirs in the campus. And of course, you can find everywhere the natural green beauty of Assam state. You can see here a lot of the buildings, you can find it. And of course, I can show you some of the building. You can see here, this is the administrative secretariat. And this is, you can say, the guest house. And here we have the hostel complex, the entire right side. And in between all these academic areas, here we have mechanical engineering and computer science, electrical instrumentation, electrical engineering, and other science humanities here. And the entire left side, you can find this all faculty and staff quarters. So this is the whole, the drone view of the NIT Silchar campus. And of course, this is one of the very important building in the institute. This is the central library of NIT Silchar. So the name of the library is Retina, Dr. APJ Abdul Kalam Learning Resource Center. This is one of the largest library in South Asia. And next is that this is the department so where I have been belong. And this department basically offering 3 degrees. One is BTech from Electronics and Communication Engineering, and MTech in 2 domains. One is in Communication and Signal Processing Engineering, and of course Microelectronics and VLSI. Then the PhD degree is offering in almost all the domain of engineering.
Sir, you will be here. Actually, sir, I will be leaving right now, and the printer guy, you will come with the brilliant character. So can you keep it?
So let me proceed the today talk. So as I said earlier, this today talk I'm going to cover one of the very famous medical imaging modality is called retinal fundus image. But this retinal image comes under the major category of image. You can say. Let's say image. So what is image? And what is the roles and responsibility of image in our day-to-day activities? We can say, I'm not going to define any what is image in terms of mathematically, because it is different to some other domains. See, I'm not going to deliver any digital image processing lecture. So my lecture is completely application oriented, how the image can be utilized for the VHDL and FPGA implementations. So in that way, as as the introduction part, we should know what is image and why we are using, how this image is taking very important part in our life. We can say, after invention of the smartphone, you can see the image is very important, play a very important role in our day-to-day activities. And of course, this capturing the image, it may be useful for in different purpose, maybe for memory and for capturing the sceneries and other kind of things, and of course for taking the selfie and other kind of purpose. Apart from that, the images may be utilized for research. So research means that, so the images may be used for either computer vision research or medical research or something else, right? And not only for this, but also the security is also very important, play a very important role in our life. So for that aspect, the images may be used for the surveillance also. So we have a lot of applications with images. Of course, this particular talk comes under the medical research. Okay, so medical research, in terms of medical research perspective, if you look into the image, so basically it comes under the medical imaging, or we can say the medical image processing. What is medical imaging and what is medical image processing? It is the process or technique of creating the visual representation of our human body. Okay, it's very simple. Let's say, let's consider one simple example. Suppose if I have some pain in my hand, right? So what I have to do? I have to be able to screen myself. Otherwise, I have to consult to the doctors. Okay, if we are going to doctor for consultation, what the doctors will do, so they will try to fix the problem. They'll find out the problem. If not able to find out the problem, then they will suggest to go for the X-ray imaging, say for example. Then from the X-ray image, so the doctor can identify what is the problem and how to address the problems. So now look into this example. So here the X-ray imaging is one of the medical imaging modality which helps to understand the, or which is help to analyze the visual representation of the body. So for what purpose? For the clinical analysis or medical intervention or something else. And most importantly, this medical images can help for the visual representation for some organ or tissue or whatever it is. So all these processes can be through the psychologically. So this is called basically medical imaging. Okay, so in terms of imaging perspective, the acquisition of medical images is very, very important in the field of medical imaging research. So I don't know how many of them belongs to this image processing researcher, and I don't know the level of audience also. I hope most of the audience or most of the participants are from engineering background, and of course the engineering college teachers. I hope so. In that aspect, I'm just going to deliver this particular lecture. See, if this analog and mixed VLSI circuit is given in the title of this FDP, but I'm not sure whether how many belongs to the signal processing and image processing background. If not, also no problem, because if based on the scope of the FDP, majority of the participant there belongs to the VLSI group. I think so. But in that aspect, this particular lecture will be helpful in two aspects. One is, if you are the beginners in this medical imaging domain, then like if you don't know any experience about this medical imaging domain, definitely this lecture can help you to understand, to learn something new to carry out your research. And if you belongs to the medical imaging or imaging community, and also you will get some kind of knowledge how to implement our image processing algorithm into hardware. Okay, so both the way I am going to present. So in that way, this particular presentation will be helpful to you. Okay, so let me start with this medical imaging perspective first. So I told you the acquisition or acquiring or capturing of this medical image is one of the challenging tasks in all the radiological department of the hospitals. So for that, we have a lot of medical imaging modality in the hospital, or we can say that in any radiological lab. So we have a lot of medical imaging modality. Say for example, first we can see the radiography. So the radiography, we can say the X-ray image. Okay. So this X-ray image can be taken for any fluoroscopy or mammography applications. And next, the very important medical imaging modality is that computed tomography, which is called CT, is normally we call it as CT scan. Okay, the CT scan is also one type of radiography technique, but it is different from the X-ray machine. So the X-ray can take in only one type of direction, but in computed tomography, we can take any kind of direction. So that is a difference between the X-ray and CT. Then the other medical imaging modality, we can say the nuclear medicine imaging and single photon emission computed tomography and positron emission tomography. So this all short name we are very familiar. Say for example, PET scan, SPECT scan, NMI scan. So these are all very famous names in the medicine domain. So these nuclear medicine and single photon and positron emission. So these medical imaging modalities, are very rarely used in the hospital until it is emergency. Let's say because why these modalities are very rarely used, because of the radiation effect, because the positron and photon and gamma rays are injected into the human body, so it will lead to some other side effects. So that's why the doctors, they will not be prescribed for this kind of modality frequently until it is emergency. Say for example, for screening any cancer diagnosis or tumor diagnosis. In that kind of extreme cases only, the doctor will suggest this kind of modality. Next is that the other medical imaging modality, we can say the magnetic resonance imaging. It's called MRI. So this MRI, you can see, we can use a lot of purpose, right? For acquiring the clear visual representation of the body, and especially in the human brain. So these all are the neurological disease, the neurological disorders. Say for example, this Alzheimer disease or Parkinson disease. So these kind of neurological diseases are diagnosed by this particular modality, magnetic resonance imaging. And of course, the recent times, the other extended version of MRI, the functional MRI, fMRI, is also very famous for screening all type of this neurological disorder disease. And next to two like the medical imaging modality, we can say is that ultrasound imaging and Doppler ultrasound imaging. These are very popular because these are all very low cost medical imaging modality, and of course these modality which is conventionally available even small clinic also. As we know, the importance of ultrasound image, like it helps to analyze the fetal movement of the pregnant woman. And sometimes you can use this Doppler ultrasound imaging for analyzing the kidney stone, to identify the location of the kidney stone, so where it is there. So in that way, so these ultrasound and Doppler ultrasounds are very famous modality. And the last two medical imaging modality, we can say the fundus imaging and optical coherence tomography imaging. These two are very special because the last two are help to acquire our retinal image in the eye. The fundus imaging can help to acquire the two-dimensional image, and the optical coherence tomography can help to acquire the 3D image. So that is the difference between these two. And this particular talk, today talk, I'm going to concentrate, I'm going to deliver only on fundus imaging. You can say the retinal fundus imaging. So the reason is that I have been working the last couple of years, we can say that almost in 1 decade with fundus images as my research, as a part of my research. So I'm going to deliver this whole fundus imaging in this lecture. Okay, let me proceed further. What is retinal fundus imaging? Or we can say, we know what is retina. And what is retinal fundus imaging? Let's see. Before understanding the retinal fundus image, first like quickly go through the anatomy of our human eye, we can say. So this is the anatomy of our human eye. So here in the anatomy, the retina is one of the part of the eye which is located is back side of our human eye. You can see here. See, this is the front portion of our eye. So the front portion we have cornea, iris and lens. But the retina is located almost back side of our human eye. Okay. So here the challenges comes here. So what is the challenge? In medical imaging perspective, basically we need image. Then only as a researcher, as a technologist, we can able to process the image, right? But capturing or acquisition of retinal image is the most challenging job because it is located at the back side of our eye. So with the help of the available conventional camera, it is very hard or very tough to capture the retinal image, or we can say the retinal position in the eye. So for that reason, we need some specialized camera to acquire the retinal image. So then only we can able to screen all type of retinal diseases, or we can say eye diseases. If you have any type of eye diseases, so the first symptoms will come under the retina. That's why we are purposefully locating, or we are capturing the retinal image in the eye. So for that aspect, we need some specialized camera, So this is the camera which is conventionally used in all eye hospitals, and of course in the medical hospitals, medical colleges. So the camera name is Fundus camera. You can see here, this is the Fundus, typical Fundus camera, which will be used in the hospital. So with the help of this Fundus camera, the retinal image has been acquired. That's why the image is called retinal Fundus image. You can see here the typical setup, how in hospital the retinal images has been acquired. You can see here, this is the typical Fundus camera, and in the Fundus camera we have the screen, the front of the machine, and normally the patient, they will be sitting backside of this machine, and the radiographer, so they will be adjusting the lens and they will be capturing the retinal image through this camera. And this captured image has been processed by the computer software, and this after removing this cropping and other irrelevant portions, then finally they will acquire the retinal image. So in that way, this camera can help you to acquire the retinal image. So with the help of the ordinary camera, it is very difficult to capture the image. Okay. So now we can see this is the typical retinal fundus image, which has been captured by the fundus camera. So primarily, this retinal image consists of three major parts. One is that the macula. The macula is the center part of the retinal image. And you can see the macula is the light darkish color. This is the center portion of the retina. And next is that the brightest part in the retina, which is called optic disc or optic nerve head. Both names are same. We can say optic disc or optic nerve head. And the third part of this retina is called blood vessels. We can say this is called vessels. It will say that blood vessels. So the retina consists of macula, optic nerve head, and the blood vessels. So why I am explaining this biological structure of the retina is that if you can able to understand this biological structure, so then only you can able to understand the research framework or the research problem in this retinal fundus image. So without understanding this retinal biological name, it is very hard to formulate the research problem in this particular domain. That's why I'm just delivering all these kind of biological names. Okay, now it's very clear. So retinal fundus imaging consists of three. One is macula, optic disc and blood vessels. Now, we'll look into the aspects of applications. So for what purpose, and in other hand, why we are acquiring this retinal fundus image. Okay. Now, the acquisition of fundus image can help in two aspects. One is to screen the eye diseases. Let's say, for example, the glaucoma. It is one of the eye diseases, or we can say it is one of the eye disease. And next is that we can say the macular degeneration. This is also one type of eye disease. And in other eye diseases, we can say retinal neoplasm and choroid disturbance, and of course the diabetic retinopathy. So these are all the eye diseases. So these all eye diseases are screened based on the retinal fundus image in the hospitals. In other way, if you have the eye disease, then this fundus image also helps to analyze the progress of the disease. So in that way, this fundus image, or we can say the fundus photography, have a lot of applications, a lot of usage, right? So in that way, we can say the fundus image is one of the most important medical imaging modality, especially to diagnose the retinal diseases. Now, coming to the other point, we can say that, like in the previous slide, I have been given some of the eye diseases, we can say. But you can see here some more eye diseases have been given in this slide. According to my own experience, there are 62 different eye diseases are available based on the literature. 62 different eye diseases are there. Just imagine that. Out of which, so these are all some frequently like reported eye diseases. And again, I have been highlighted some of the eye diseases in the red color. So these red colored eye diseases are most degenerative diseases. That means that these diseases are frequently affected by the humans. The number one is that AMD. So basically this disease is called age-related macular degeneration. So this particular disease will be affected by the people more than 50 years of age. Let's say our grandma or grandfather, we can just see the experience. They will very hard to find their vision. So they will try to figure it out with the help of the hand, whether who is coming in the opposite side because of this effect, AMD disease. Maybe we also may affect this particular disease, maybe after 50-55 years of age. This is basically the disease is called AMD. And the another disease, like everybody's might heard this disease, cataract, right? So in the cataract, like the white color bulb, like that will be created in the eye lens. So that is the first symptoms of this cataract disease. So that we come across this disease. And next is that the diabetic eye disease, or we can say the diabetic retinopathy. Okay, so this disease is affected by the diabetes patients, or we can say the diabetes mellitus. And those who are having the diabetes, then they have more chance to lead this disease. And once the diabetic retinopathy is coming, then the diabetic patients, they will lost their vision if they are not treated timely. And next is that the other very dangerous disease, eye disease, is called retinitis pigmentosa, we can say. So this is the gene-related disease. So if the parents is having this kind of disease, and of course their child also have a chance to affect these diseases. And another one is the glucoma. So this disease normally comes for the under eye pressure. If your eye is under pressure, then it will have a chance to lead this disease, glaucoma. Okay, so out of which a lot of eye diseases are there. So I have been working in almost all the eye diseases as my part of my research. And of course, recently I have been working with retinal detachment also. Okay, so these are all the eye diseases. Let's have a quick glance in terms of imaging perspective of these most degenerative eye diseases. Say first one is the cataract. You can say here the first clinical symptoms of cataract, the white color bulb that will be created in the eye lens. And if you have the normal vision, you can see here the image will be like this. And if you have the cataract, then what happens is that the image will be blurred. Image will be blurred like this, right? And next is the disease is called AMD. We can say the age-related macular degeneration. So this disease is basically affected. The center part of the retina is called macula. We know what is macula. We already heard from the previous slides. So it is affected the macula. That's called, the disease is called macular degeneration. And basically it is affected by the elderly people. That's why it is called age-related macular degeneration. So if the center part of the vision, I mean the macula is affected, then of course you can see the effect of vision in the image. The center portion will be lost. Okay. And the background will not any issue because other retinal part will not be damaged in this AMD. That's why the center part will be lost. That's why the elderly people, they will very hard to recognize the vision, the center portion of the vision. And with the help of the background vision only, they will be able to identify the objects. Okay. This will happen for the elderly people. And if you see in terms of the age-related macular degeneration, so how the impact of this AMD disease will be affected by the elderly people. So that I can show you with one small animated video, then you can understand basically what's happening inside in the retina. Yeah, you can see here the effect of AMD. It will be completely, affect the macula part. That's why they lost the center vision. Next is that glaucoma. You can see here. This is the second largest vision loss disease worldwide. The statistics is that most of the computer engineer, we can say the software engineers, are affecting these kind of diseases because they have been spending more time with computer, like more than 12 hours per day. Then what happened? They are not properly, slept in the night. Then the morning, their eye will be under pressure. Okay. So how to find your eye is under pressure? What is the symptoms for that? So in the normal condition, your eye liquid will be inside the eye. Okay, so suppose if your eye is under pressure, then the eye liquid will come out from your eye. So that is the symptoms that your eye is under pressure. Let's say this will happen in our own experience. Suppose if you have a, happy to see the, go for second show cinema in the midnight. So it will almost start from 10 to 1 or 2 p.m. Sorry, a.m. in the morning. Then after the second show cinema, you go for bed. And if you wake up in the early morning, maybe going for office and for college, but what happens is that that day you can feel your eye liquid will come out from your eye. You may experience in your day-to-day activities if you are not sleeping properly in the night sometimes. Then this is the condition like that your eye is under pressure. See, what happens is that if this eye pressure is continuous, then it will lead to this particular disease. It's called glaucoma. So basically, a lot of people, they have been working with this, BPO and KPO jobs than the entire night. So they will be have more chance to affect these kind of diseases. That's why the lot of you can see the eye hospitals are coming in India, because most of them are working with the IT employees, and of course they have been affecting these kind of diseases. And that's why, just imagine 5 to 10 years back, very less number of hospitals in India. But you can see here, even small town also we have eye hospitals. The reason is that a lot of patients are coming. You can see a lot of advertisement in the TV also. You can see Nangarko, please come, we'll treat you. Some kind of advertisement also you can able to see. The reason is that a lot of, in the statistics says that in India, a lot of eye patients are coming. That's why they need a lot of business. That's why they are started this kind of eye hospitals. And this is the whole history of this particular disease. And now let me go for this other disease, is called Retinitis Pigmentosa. So this is also very dangerous disease. And basically this disease has been affected from the parents. From the gene transfer, so the child also will affect these kind of diseases. And the hard thing of this particular disease, it is covered the black pouches in the whole background of the retina, and that's why the whole vision has been affected. Maybe in somewhere very small portion of vision they can able to see here. This is the disease called retinitis pigmentosa. And now we will go to the other disease, is called diabetic retinopathy. It is the world largest vision loss disease in the world, you can say. Okay, and especially the people, those who are having the diabetes disease, so they have a more chance to affect by this disease. India is the diabetic world, as you know, and India is having largest number of diabetic retinopathy patients. And of course, in developing countries like India, we have a more population, but the number of eye doctors, we can say the ophthalmologists, are very less in India. So how to treat the large diabetic patients? Okay, so that reason we need some kind of computer-aided diagnosis, or we need some kind of automated diagnosis from the researcher to screen all these related eye diseases. That's why a lot of research groups are working to develop an automated eye disease screening, or we can say the computer-aided diagnosis of eye disease in worldwide. Even my research group, one of my research group also working in this retinal image analysis, we can say. You can see the impact of diabetic retinopathy. So it will affect in either foreground, background, or center vision, almost in all. So that's why it is a very dangerous disease. Of course, it is the largest vision loss disease in the world. Now you can see the impact of diabetic retinopathy disease from the healthy one, from the normal one. So from the normal one, we have seen the retina. So basically we have the features called fovea, or macula, or optic disc, and blood vessels. And if you have the diabetic retinopathy,
Dear participants, due to some technical issue, resource person get lifted. Kindly hold on, he will join soon. Sir, sir, kindly unmute your mic, sir.
Yeah. Yeah. So previously I don't have control to unmute.
Okay, okay, sir.
Yeah, now it is fine.
Okay, sir.
So sorry for the interruption. I have some network issue. So I just disconnected. Yeah, I hope it is visible.
Yes, sir, visible, sir.
Yeah.
Okay.
So now we can able to understand the normal eye from the diabetic retinopathy eye. So we have a lot of lesions that have been created in the eye because of the effect of the diabetes disease. Okay. Now we can clearly understand the retinal diabetic retinopathy feature from the retinal image. So the normal retinal feature, as we know, this is the optic disc, we can say, and this is the blood vessel. And of course, the other feature we can say, this is called microaneurysm. And these parts are exudates, can say. And this is called hemorrhages. And this is called the cotton wool spots, can say. So these are all these retinal features that for the diabetic retinopathy eye. Okay. So now, how these retinal features are, helping to diagnose this diabetic retinopathy disease. See, based on the International Severity Scale of Diabetic Retinopathy Disease, so the diabetic retinopathy that has been divided into two major types. One is the non-proliferative diabetic retinopathy and another one is the proliferative diabetic retinopathy. So how these diseases are classified into two based on the retinal features, or we can see the based on the diabetic retinopathy features. So let's say in further, the non-proliferative diabetic retinopathy has been divided into further mild and moderate and severe stages. So this all comes under, depends on the diabetic retinopathy feature. Let's say the first one is the microaneurysm that you can see here. This is a microaneurysm. So it is a very small, part, red dot that will be created in the retina. And of course, this is the first clinical symptoms of diabetic retinopathy. That's why if the eye, retina is having only microaneurysms, then the retina comes under the mild non-proliferative DR stage. And if the count of microaneurysm is getting increased, and it will lead to the other stages is called moderate. And if more than 20 microaneurysms and hemorrhages that have been created in the eye, then it's going to the severe. Okay, and the neovascularization and the pre-retinal hemorrhages has been created, then of course it leads to proliferate. So in that way, this diabetic retinopathy diseases are grading, are classifying based on the features. Now, this is the whole effect of diabetic retinopathy in the retina. If say, for example, if the eye is under one first and second stages, And in hospital, we have the laser treatment. It is very easy to treat. And if it leads to the advanced stages, it is very hard to treat this particular disease. There is the only issue that they lost their vision. So that's why the early diagnosis of diabetic retinopathy is very, very important for a diabetic patients. So that's why the doctors are suggesting, if you have the diabetes, at least 6 months once, you have to visit to the hospital and you have to consult it, whether you have diabetic retinopathy or not. Okay, if in the early, if we can able to find in the early stage, then it is very easy to treat. Otherwise, the patient, they have lost their vision. Okay, so this is the whole effect of this diabetic retinopathy. Okay, how we can able to diagnose this diabetic retinopathy through the retinal features? Because as I said, so what is the role and responsibility of the technologist or the engineers, or we can say the researcher, to address this diabetic retinopathy disease? Because in like our country, we have large diabetic patients, but number of doctors are very less, you know. So they need urgent, necessity to develop some computer-aided diagnosis for automated diagnosis. Then only we can able to screen the large number of patients within the short span of time. So that's why, a lot of researchers, they have been working in this related area to diagnose the same. Okay, so in terms of research perspective, how the diabetic retinopathy has been screened, these retinal features, based on these features, we can say the microaneurysms, exudates, cotton wool spots, you can say blood vessels, and hemorrhages. Among all this retinal feature, the microaneurysm is the first clinical symptoms, as I said. So, for early detection of diabetic retinopathy, so basically, we have to localize, or we have to segment these microaneurysms from this retinal image. From that way, we can go for the early diagnosis of diabetic retinopathy. Okay. And now, in other way, for diagnosis through the computer, we can say the computer-aided diagnosis of diabetic retinopathy, based on the research framework, we can do with any one among these three. Either we can automatically detect with the help of conventional image processing approach, or we can go for the machine learning approach, or we can go the deep learning approach. So any approach we can able to do that. Okay, now from this point, I'm just getting into how the diabetic retinopathy disease can be screening or can be detected based on the conventional image processing approach. Because basically, as an image processing researcher, so we have to do with the conventional processing. Okay, and of course, we can use these kind of FPGA implementation, or we can say the hardware implementation for all these three kind of approach, either conventional approach or machine learning approach and deep learning approach. Among all, this conventional image processing approach is most predominant approach, especially with the help of hardware. If you use machine learning and deep learning for the hardware approach, and especially this VLSI system hardware or FPGA, they need large computational facility. So then only we can able to screen those diseases. But if you go for the conventional image processing, we no need to go for it. It's not required any large computational facility. Even one simple text of computer is more than sufficient for that. So that's why I'm just going to focus on this particular lecture, conventional image processing. The same way you can go for machine learning, deep learning, but accuracy and other things are other issues. But let's coming to concentrate on only the hardware part. Okay, so now basically in terms of the image processing perspective, for automatic diagnosis of DR, so we have to follow this particular step-by-step procedure. So for screening this disease, basically we need the retinal fundus image. So this image, we have the two options. So either we can collect from hospital or we can collect from the online databases. Okay. So we need large amount, large amount of images that we have to collect it first. Then we have to use our own, this, we can say the conventional approach. It will start from the pre-processing. And of course, whenever it is required, we can go for any segmentation or feature extraction or any selection or classifications based on that. So this is the basic typical, the general approach to screen the diabetic retinopathy using conventional image processing. And here in terms of research, so we have to propose or we have to use our own pre-processing and segmentation and feature extraction algorithm for automatic diagnosis of LDR. Okay, so from this, my approach will be entirely going to localize or screening of these microaneurysms in the retinal fundus image. Why I'm focusing only on microaneurysm? Because as we know that microaneurysm is one of the first clinical symptoms of diabetic retinopathy. That's why. So I'm just focusing only on microaneurysms. So I've been working a lot of research problem related to these microaneurysms. So I'm just going to highlight only two of my work in this lecture. Say for example, this you can say the localization of these microaneurysms in retinal fundus image, like how we can localize. So basically, as we know, the microaneurysm is the small red part in the retina. So this is very small in size, and we have to play a lot of research challenge in this. So how to do that? How to localize this? So basically, I have been followed this particular workflow. Let's say pre-processing, segmentation, feature extraction, then finally the microaneurysm localization. And here I have been played a lot of mathematical manipulations and a lot of algorithms. So those algorithms I'm not going to highlight here because this article is available in my Google Scholar link. So if you have interested, you can go through the paper. I have been given all this mathematical framework and all these algorithmic and algorithm in this particular paper. The only thing is that I'm just highlighting how we are going to detect the microaneurysms. So this is the way. And this particular work, like we have been used, we can say the some diseased image, we can say the abnormal retinal image. So you can see here this particular image, the A image, we have a lot of microaneurysms having. And if you apply this particular methodology, finally the K image, we have been segmented, we have been localized the microaneurysms present in this particular retinal image. So you can see here a lot of microaneurysms are there. So based on that, if you use any classifier, then the classifier, they will automatically suggest this particular disease in diabetic retinopathy or not. If it is, then what is, whether it is a mild stage or moderate stage or severe stage, based on the number of microaneurysms present in the retinal image. And of course, the microaneurysm has been occupied, the area of occupied in this particular image. Okay. And you can see here some other retinal image also has been tested, this particular image. And this work has been tested. The three publicly available online retinal data sets. One is DRIVE, STARE, and Diabetic Zero. And of course, this method has been given very good results in all the data sets. So this is the one work which I want to show you, like how microaneurysms has been, how the diabetic retinopathy has been screened based on the MA. And next, recently, one of my research scholar, he has been working with microaneurysm detection, the detection of microaneurysms through the local non-film filter. So here, what happens is that why we are proposing this non-local mean filter. This filter purposely is proposed in the pre-processing stage of this approach. So as we know, in the conventional image processing approach, the pre-processing play a very important role, because like either it may be online image or it may be a real-time image. During the acquisition of this retinal image, like a lot of noise and imaging artifact may be created. So these kind of noises or artifact we have to clear in the pre-processing stage itself. Then only we can able to go for the either it can be segmentation or feature extraction or any other conventional image processing steps. So in that way, so this particular, the proposed filter has been effectively removed all the noises and imaging artifacts in the given input retinal fundus image. Then once this image is further processed, like pre-processed, then the other conventional image processing approach we have used to detect the MA, you can say the microaneurysms. And this is the whole workflow of that particular work. And you can see here, this is the step-by-step outcome of this particular work. And this is, say, you can say here, this is the retinal image that has been given as an input. And once if you apply the step-by-step approach, then finally the MAs are detected. So here you can see here very small, dot, white dot you can able to find. So these are all the microaneurysms which is present in this image. And of course, this particular work has been tested in other retinal data, like online data sets, say for example, AICTE, diabetic DP0 and diabetic B1 and ROC. This is retinal online challenge ROC data set. So here, this is the things which we have to do. Like this is the things which have been done in the last year for this MA detection. Okay, apart from this, 1 minute. Okay, so बचेगा ठीक है Sorry for the interruption. And see, you can see here a lot of data set that have been used for this work. And most of this work has been given very good results. Now, from this point, if you use this kind of computer-based approach, or we can say the software programming-based approach for this automatic diagnosis of diabetic retinopathy, we have to face a lot of challenges. Say, for example, we need the dedicated computer operator in the hospital to screen this image, right? To screen this particular disease. And in other way, for storing this image, we need the large memory size, we need the extra hardware, or we can see these kind of huge memory space is required. And of course, these all medical images are very large in size. Then the time complexity is also the other challenge, the other issue in this software programming. Okay, so while reading this particular image, so basically what we'll do in the conventional image processing, we have to resize the image. So once the image is resized, then there may be a chance to miss some of the retinal features, especially because these are very small in size, you know. So for addressing these kind of challenges in the software part, so as the technologies, we can able to propose, or we can able to focus on the hardware part, like for the same kind of problem, we can say we can use this, the conventional field programmable gate array. We can say the FPGAs for addressing these challenges, say the time complexity and memory space, and also if this particular software approach, it may be implemented into hardware, then no need for any, this trained manpower or any manpower is required to operate the computer. If the hardware is ready, even in the doctors or even the nurse also, they can able to operate those machines once it is given the training. And in that way, so these kind of research problem, we can say the microaneurysms or exudates or something else, that we can able to detect or we can able to segment with the help of this like FPGAs. So for that, basically, we need for implementing this hardware, basically the Xilinx system generator is required. And of course, the hardware co-simulation is also required in the system or in the processor. So basically, this is a very, one of the interesting problem, because how the image is going to implement in FPGA. Okay, the reason is that whenever we are doing any kind of images, with the help of this tool or any software, say for example, either MATLAB or Python or whatever it is, so we always used to process the two-dimensional images, right? But when we are going to use this kind of hardware, we need the one-dimensional image, right? Then only we can effectively process the image in the hardware. So in that way, in that case, if you see, if you want to use this FPGA for implementing this kind of application, basically we have to go for the conversion from 2D to 1D. Let's see. So in a Xilinx system generator, so these are all the whole 5 processes we have to do for screen or to segment these kind of retinal features. First one is that to transform the two-dimensional input into one-dimensional. And second, so we have to use, or we have to design the proposed model in Simulink, or using XSG, that is the setup which has been used in the MATLAB, basically. And next we have to perform the co-simulation, then we have to generate the synthesis HDL code, then finally the hardware software co-simulation that we have been performed. So these are all the 5 steps we have to generate, we have to process for the Xilinx system generator. So now from this perspective, so initially we have to go for the image conversion from the two-dimensional to the one-dimensional, because we know the image is a two-dimensional filter or two-dimensional matrix. So from this we have to convert into one-dimensional. Then only it is easy to implement in the hardware. Now, if once the conversion has been done, then we have to design the flow of the model. So the flow of the model, we can see here, say for example, if we have a MATLAB tool, so here what we have to do, so we have to do all this input image, or if you could do any conversion, that we can do it in the MATLAB part. And from this, you can go for the Simulink system generator. So in the MATLAB, we have the Simulink tool. So you can, with the help of Simulink, you can go, or we can design your own conventional image processing steps. Say, for example, if you want to go for any edge detection, or thresholding or segmentation or segmented image. So these kind of conventional system that we have been designed based on the Simulink. Then this Simulink model, this Simulink unit that we have been interfaced with the hardware core simulation of this device. Say we can say RTL, HTL code or Xilinx implementation flow, bit stream, or we can go for the FPGA development for it. Suppose if you have some FPGA Spartan 3, 4, and 5 series, that also you can use for the same purpose. Okay, so this is the design flow that basically we have to follow that. And once the design flow has been followed, then we have to build the architecture in the model, in the hardware part. So what are the architecture we have to give? Say, for example, if you want to edge detect the image, and suppose if you want to segment the image, then accordingly you have to develop your own architecture for the input image. Okay. Suppose if I am given the grayscale image here, then the whole conventional approach that we have to design with the help of this architecture. Then once if you fit the output, then finally if you use this segmentation unit and other add sub unit, then it will be converted. You can able to get it the edge detected image or the segmented image. Okay, in further with this architecture model, so we have to go for the hardware core simulation, right? If you use FPGA, so basically we have to import the JTAG, we can say the JTAG core simulation. So here what happens is that JTAG simulation, it is also inbuilt in the Simulink, so that we have to enable it for the Xilinx environment. Then finally we can able to edge detect and segment the image. Okay, and once if you done all this process, then basically if you given the input image like this, the grayscale image, then you can see here the edge has been perfectly detected from this input, and of course the image, so whatever the abnormal feature that has been given, that has been present in the input image, so the exudates and microaneurysms, also it is segmented in this particular image, the third image. This is also the another sample image, as you can see in this particular slide. Okay, so in that way, so you can use the the hardware model, or we can say the FPGA or Xilinx model for implementing any type of retinal research problem. You can see here in the hardware itself, in the MATLAB itself, we have the default HTL code generator. So that generator can help you to run the basic code. So as I said, this MATLAB environment you can use for both the software as well as the Simulink part. Okay, so for the better understanding, say for example, if I'm having, this is MATLAB which I'm having in my computer, like I can show you. Yeah, you can see, I think can able to see. Can you able to see my MATLAB screen?
Yes, sir, visible, sir.
Yeah. See, this is my MATLAB screen. And in the MATLAB tool, as you know, this, we can say the Simulink environment is there. See, suppose if you click the start Simulink, then you will get the Simulink window. So this is the whole Simulink window. And here in this Simulink window, you can be able to design, so these kind of architecture, you can see this kind of architecture. It is just a drag and drop environment. Okay, so all these drag and drop buttons are available here. So in the menu, so you have to be design your own the drag and drop environment, either the architecture. So once you build the architecture, then in the MATLAB, so you have the freedom to generate the different code. So for that, just you click this kind of simulation here. You can see here, the link is available, and you can just click model configuration parameter link, or you can press Ctrl E. and just if you click, you will get the another small window in the simulation. Here you will get a lot of code generation option in the MATLAB. You can see, for example, if I click the code generation, you can have a freedom to generate the C language.
Sir, actually, Simulink screen is not visible, sir. Only that MATLAB programming screen only visible, sir.
Okay, okay, just a minute. Is it visible?
Yes, sir. Now visible, sir.
Yeah.
Okay.
So now in the simulation link, you have the option to generate all type of code. Say for example, if you click the code generation, you will get C language code or C++ language code. And next you can see the last option, the HDL code generation. You can see here in the HDL, so the language that you can select either if you want VHDL or Verila. So which language you want. So both the MATLAB will support if you can select. And also you can generate the HDL code. And if you click the generate button, so automatically the code will be generated. So once the code is generated, then you can easily to enable your your hardware model, or you can say the FPGA model through the JTAG cable to your serial port. Then if you run the code, automatically your system, the FPGA, will perform for the respective applications. So in that way, so we have to use this our FPGA model for these kind of applications. Okay, so at present I don't have any FPGA kit in my office, so I'm just telling you only the procedure how to do that. And like with this available input, you can search some YouTube videos. So a lot of YouTube videos are available how to like generate HDL code using Simulink, how to generate HDL code using the MATLAB code. So you will get a lot of references, I can say. Okay, so in that way, so you can able to do a lot of hardware implementation with the help of this kind of Verilog and VHDL, and of course this kind of FPGA kit. Okay, so in that way, so you can able to do a lot of research problem, and you can do a lot of research ideas like in this kind of like applications, especially how medical applications can be clubbed with this hardware model. Okay, and so in further, like as I given one sample architecture for the microaneurysm detection in the retinal fundus image, but also as a researcher, I can suggest you some of the key research problem in the retinal image analysis. Especially, you can use both hardware and software implementation for the diagnosis of DR through the following retinal features, such as other than the microaneurysm, we can use exudates, cotton wool spots, and blood vessels, and hemorrhages, and other things. So with help of to screen these kind of retinal feature, you can easy to diagnosis of this diabetic retinopathy disease. Okay. So with this, I am just concluding the today talk, the today lecture. So today I have been delivered the automatic diagnosis of the retinal disease, especially in the diabetic retinopathy. So how we can able to screen through the retinal feature, as well as how we can use the hardware, especially this FPGA and other Verilog environment for screening the diabetic retinopathy disease. So we can use these kind of model for either computer-aided detection or computer-aided diagnosis, and of course we can use for any type of quantitative imaging tools, or we can use the decision support system. So this is the common idea, and of course this is a very simple and short lecture how to use this how to start this hardware part for the medical imaging perspective or the medical imaging diseases, or you can say the medical imaging domain. Okay, so we can see most medical imaging researchers, so they are concentrating and working with two-dimensional image, but in the recent time, the researchers are migrated into 2D to 3D and 4D images, because these are all better than the 2D images. So in the future direction and the area of medical imaging, so almost it is going to convert into 3D and 4D. Okay, so with this, suppose if you have the interest to work with all these kind of retinal image analysis, you need the data set. You need images. So then only you can able to carry out your research. So here I have been supplied a lot of data sets, retinal online available data set. So if you want to download any images, retinal image, you can refer these data sets. It is freely available for the academicians, so you can able to download it. And with this, I want to suggest one more open source, openly available, computer software, especially for understanding of computer vision and image processing steps, which is called, this tool is called CVIP tools, which is computer vision and image processing tool. So this tool can help you to understand all the image processing fundamental without writing any code. So it is just a drag and drop environment. So you can easily to understand all the concept of the image processing with the help of this tool. So this is freely available. So you can able to download and you can experience this tool. And of course, if you are the student, this tool is very much helpful. And if you are the faculty, and also this particular tool can help you to teach the image processing operation to your students. Okay, so these are all the references which I have been used for these presentations. And of course, these are all, the very evergreen textbooks in the field of medical imaging, and of course the medical retina, to start your own research. Then finally, I'm just before the conclusions, I would like to say that so like in AICTE and especially in my institute, it's offering a lot of PhD fellowship opportunity to the students. And if you want to acquire if you want to take the PhD admission in AICTE, so you can just feel free to write my mail. I can help you to take the PhD admission in the institute. And basically, this department is offering two mode of PhD. Two mode of PhD admission. One is the full-time and another one is the part-time PhD. So for a full-time, so the government is given 31 rupees stipend per month to carry out your research. And for part-time, so they will not pay any amount. So you can work anywhere from the country, and you can come here and register. And if you finish the coursework in the campus, then the remaining tenure you can work anywhere in the country. So once if you fulfill the criteria of the institute, then the institute will offer the PhD degree. Then apart from this, from my own research lab in biomedical imaging lab, I have been given a lot of internship opportunity to the students of BTech, MTech, as well as the PhD students. And of course, a lot of faculty, a lot of engineering college teachers also working with my lab under my with collaboration of the NIT. So that also we are doing as a part of service to the nation. So if you feel free to do any kind of internship or any type of fellowships, so I feel free to write to my email, or you can just call to my mobile. I'm ready to help you in any aspects of that. So with this, so I'm just concluding this today's talk. I hope this talk may be useful to you. So if you want any clarification, any queries, so I'm happy to answer some queries, please.
Dear participants, if you have any doubts or queries, you can ask now.
No questions?
Yes, sir. I think there is no questions from participant side, sir.
Okay. So whether my talk is interested or not, I am not sure.
It's a very informative session, sir. Let me wind up the session, sir.
Yeah.
Talent wins games, but teamwork and intelligence win champions. In this way, I'd like to thank our today's resource person, Dr. R. Murugan, Assistant Professor, Department of ECE, National Institute of Technology, Silsar, Asham, for providing a wonderful session in this FDP. Darkness cannot drive out the darkness, only light can do that. On behalf of management and organizing committee, we once again thank you so much for lighting the minds of this gathering. Thank you so much, sir.
Thank you. Thank you very much.
Thank you, sir.
Thank you. See you. Bye-bye.
Dear participants, the day 9 session to attendance and the feedback link is posted in chat box. Kindly fill its own. It will be open up to 30 minutes only. While filling the feedback form, kindly choose your respective FTP ID. Thank you all.